A very good afternoon to all the participants and our esteemed speakers, Mr. Samuel Winthrop and moderator Ms. Subha Priyadarshini from Springer Nature in this webinar on research data publishing, gaining credit for making data fair. I'm Rita Sharma, working as Information Analyst at Knowledge Resource Center, TERI. Welcome you all in this webinar. We are organizing this webinar as prelude to our forthcoming conference, ICDL 2019, from 6 to 8 November 2019 at India Habitat Center, New Delhi, India. In every 3 years, ICDL conference was held with contemporary topics which have global relevance with localized focus. TERI, in collaboration with multiple government, corporate, and private organizations, is organizing the 6th edition of ICDL with theme Digital Transformation for an Agile Environment. ICDL 2019 will bring together a plethora of digital experts to discover how digital technologies are taking control of businesses and driving further digital innovation to new levels. The ICDL 2019 will host a vibrant mix of academic paper presentations, keynote addresses, discussions, workshops, and exhibitions by national and international conference delegates. Further to this, ICDL 2019 has identified Industry 4.0 as one of the key areas where digital transformation is undergoing a paradigm shift. Ladies and gentlemen, the highlights of this year ICDL 2019 are that we have national speakers 40, international speakers 25. We have received more than 100 papers for oral presentations. The eminent personalities like Mr. Winton G. Cerf, who is the co-inventor of Internet and also known as one of the fathers of Internet, also connected to us by sharing his video message on digital learning, which you can view through ICDL website. We have also launched the ICDL app, which you can download from the Google Play Store and the App Store. This is in the first time of history of any digital library conference that the Special Library Association President Mr. Hal Kilcourt and the President of IFLA Ms. Christine McKenzie is coming to deliver the keynote address. And we have also launched the digital engagement platforms such as storytelling, webinars, and virtual conference to engage the participants before and after the conference on the contemporary topics related to digital transformations. We are receiving a very good response at these platforms from all over the world. I request you to please visit our ICDL 2019 website for more updates and also register and participate to witness this mega event. Today's webinar is another addition to the ICDL 2019 digital engagement platform, and we are very thankful to our esteemed speakers to accept our invitations and to be a part of this webinar. The moderator of today's webinar is Ms. Subha Priyadarshini, Chief Editor, Nature India, and it's my privilege to introduce her amongst you. Ms. Subha Priyadarshini is an award-winning science journalist and currently the Chief Editor of Nature India. Nature Research India portal, she has been keenly following the evolving science, research and innovation climate in Asia through the last couple of decades. Through Nature's India's many workshops and outreach activities, Subha trains Indian scientists in science communications and presentation skills. In 2017, Subha mentored the first ever FameLab India competitions organized by British Council in India to hunt for the best science communicators and presenters across the country. With this, I hand over this virtual session to you, Mr. Subha. Please.
Thank you, Rita, for that wonderful introduction. It's my pleasure to now bring to you Samuel Winthrop, who is a journal development manager for research data and works in Springer Nature's London office. In his day job, he develops products and services to aid Springer Nature's authors and editors to share and use research data. His goal is to help publishers, authors, and other players in the research data ecosystem adopt and increase data sharing practices and open science through new products, policies, and services. Before joining the Research Data Group, Samuel was the publishing editor of open access journals in chemistry and Data Sciences at Springer and Biomed Central. In an STM publishing career that he began in 2010, Samuel has worked at the Science Navigation Group on the post-publication peer review processes at F1000. He is a medicinal biochemist by training and graduated from the Leeds University in the UK and the University of Würzburg in Germany. I'm told that in his spare time, Samuel enjoys mountaineering in his native North England countryside. So you're welcome to bring him all the uphill questions after his session. I'll hand it over now to Samuel directly so that he can take us through today's webinar.
Thank you very much. That was a wonderful introduction, and thank you as well for the invitation. It's a great pleasure to be here and a great pleasure to be able to talk to you about something that is a growing trend in research and something that I think is going to be a key aspect to the processes that publishers and researchers are going to interact with. So yes, my name's Samuel Winthrop. I'm what's called a journal development manager working in the research data group at Springer Nature. And this is going to be a short overview of what research data publishing can do for authors and researchers to allow them to get credit for making data fair. So first of all, I thought we would talk a little bit about why share data in the first place. We talk a lot about it, but we don't often talk about the benefits associated with sharing data. And to do that, I thought I would first introduce, for those who haven't come across it, the principles of FAIR data. So FAIR is an acronym for findable, accessible, interoperable, and reusable. And these are a set of principles that are agreed as an international standard for best practices for research data. So by findable, we mean researchers making their data findable by other researchers, allowing them to be accessible for researchers working in that field so that you don't have to simply ask a researcher to deliver the data on a USB disk or via email, and interoperable so that they can be used in different scenarios and by different software, and reusable so that they can be used in other research and continue the process of sharing data and using data in other research projects. So why should we share data? What's the case for sharing data? So the first point I wanted to make is related to what we're calling the reproducibility crisis. So in science at the moment, we hear the term reproducibility crisis, but just to put some numbers on this, a survey that Nature conducted showed that a large chunk of researchers, over 70%, couldn't reproduce the work of others. And perhaps more worryingly, more than 50% of researchers couldn't reproduce their own experiments that they had published as research papers. Now, this isn't because the research is flawed. This is because the researchers don't have access to the high quality data that they would need to reproduce the study. On a slightly more optimistic side, data archiving can double the publication output of studies. When you have that data associated with your research, it makes it more productive and more efficient. Research articles that are connected in some way to their open data are cited up to 50% more, according to some of the studies we've undertaken. In terms of societal benefits, here are two case studies, famous case studies of research projects that are associated with open data. The Human Genome Project is estimated to have contributed $1 trillion to the US economy in its first decade through the data behind it being accessible. Closer to these shores over here, the European Bioinformatics Institute estimate that they've made £1 billion of efficiency savings through allowing researchers to access data that they might have otherwise missed or had to reproduce themselves. The EU itself has run an analysis on not having fair research data that shows that it potentially could save 10.2 billion euros per year. And this is through researchers not having to redo research that's already there, not having access to research that they might need to increase their studies output, and the general efficiency and benefit to research that having open, accessible, in other words, fair data brings. So if it's such a good idea to share data, why are we not seeing large amounts of data being shared? Why is it not normal practice in the research community? We undertake a lot of surveys talking to researchers and authors about data sharing. And in particular, we're interested in the barriers and lack of motivation around research data. So this is just a brief overview. I won't go into huge amounts of detail of the numbers, but what it illustrates is that there are a mix of motivations that are currently lacking and barriers that are currently in place that prevent researchers from being incentivized to share the research data they produce. So some of those, for example, if the authors or researchers were more aware of the public benefit of data sharing, if they were able to get proper credit, if they knew what the funder requirements are, these are the sorts of things that would encourage them to share their research data. And conversely, the fact that they are often unsure about copyright and licensing around research data, they're not sure which repository to use, these are barriers that prevent them from doing so. So we've taken a lot of this data and we produce in my group in Springer Nature white papers around common practices in data sharing and what the state of play is. And this year, in April, we published a white paper called 5 Essential Factors for Data Sharing, where we distilled the results of a survey of over 11,000 researchers around the world into what we think are the 5 essential factors that we need to work on to encourage data sharing. And this is just a quick graphic to show you the 5 factors we came up with. Now, these are not factors that any one player can do everything for. This is not something that publishers alone can fix, nor is it something that researchers alone can fix. But if researchers, authors, publishers, funders, and institutes all work together to change the current ecosystem, then this is something that will lead to a greater uptake in data sharing as a common research practice. So the 5 factors that we underlie are clear policy, so allowing authors to know exactly what is required of them, either from a funding perspective or from a journal perspective. Better credit for the research that they're publishing. Explicit funding, so that they have funding available to engage in, say, data management plans or research data sharing practices. Practical help to let them know, to assist them with depositing data in, say, repositories or knowing which journals support data sharing. And training and education, which we run a lot of in the Nature Research Academies, for example, but training and education around research data overall. But the one that I would like to focus on that relates specifically to publishing itself is better credit. So that's better credit for where researchers have shared their data. Currently, often in institutes or for funders, it's all geared around credit for writing research papers, regardless of the data that's associated with it. We would like to have more options for authors so that they could gain equivalent credit for sharing their data. And the surveys we've done have borne out that this is an important aspect for researchers. So you can see there that large numbers of researchers would value citations to data sets, for example, as much as they would a paper. And a very small number of researchers think they're getting enough credit. In other words, most researchers don't feel they're being valued for sharing data in the same way that they are for producing research papers. And so this is where research data can come in. Research data publishing allows researchers to gain credit for sharing their research data. And I would like to walk through some of the practices we've undertaken in Springer Nature, some of the ideas we're piloting, and some of the options that we present to authors for this. So that we have a number of collaborations and initiatives to promote credit and recognition for sharing of data. So one of those I briefly mentioned before is the idea of a data citation. Data citations allow researchers to get credit in the same way that they would for an article. Data publishing options in peer-reviewed journals allow researchers to publish their data and receive the sort of credit that they would for a normal research paper. And 2 of the journals that we have in this field are Scientific Data, a dedicated research data publishing journal, and BMC Research Notes, which publishes short data descriptions. Sorry, I think we're having a slight technical difficulty here. Okay, apologies for that. So yes, as I was saying, there are two dedicated journals that we operate, Scientific Data and BMC Research Notes, both of which allow authors to gain credit for publishing their data sets. So on Scientific Data, sorry, we're still having the same problem. Apologies for this. Probably something to do. Okay. So Scientific Data and BMC Research Notes. Looking at Scientific Data publishes dedicated data descriptors. So this is where researchers can upload data sets as they would a research paper, and our dedicated editorial team peer review the paper, but based on data sharing practices, data management, data-focused peer review, in other words. It has an integrated submission system that works with data repositories so that authors have options to deposit their data in the repositories that we would advise as being dedicated to a certain discipline or community, so genomics, for example, or gene transcription. And it's a broad scope journal, so it looks at all areas of natural sciences. It allows researchers to gain credit for sharing their data in the same way that publishing an article would. It's a fully open access journal, so that's helping with the findable aspect of FAIR data. And it's focused on data reuse, so allowing researchers to access the data produced and reuse it in other research environments. So if we compare the data paper to the traditional journal article, in the data paper, we have methods and technical analysis around the quality of the data, but we do not look at tests for new scientific hypotheses, so no conclusions or findings. That's something that can come later in your typical research paper. There's a quick display of a Nature paper there, for example. In the Nature paper there, you have the hypothesis testing, you analyze the data and you draw conclusions. Whereas in the data paper, the questions are, what did the researchers do to generate the data sets? How were they produced? Where is the data stored? And who did what and when? On Scientific Data, we have fully open data policies, so our editors and peer reviewers must be able to review the data sets, and we check whether the links to the data sets work and that the data are hosted in a repository that meets our policies. At the time the paper, the data descriptor, is published, the authors must publicly release the data under terms that allow wide reuse, in other words, making data fair. BMC Research Notes forms another angle to our data publishing activities. So BMC Research Notes publishes an article type called a data note. And similarly to Scientific Data's data descriptors, these are pure descriptions of data without any conclusions or research hypotheses to be tested. But they're a much more lightweight version of the data descriptor. This is a brief graphic that shows you what a data note looks like. It has a description of the data. It explains the objectives the authors were after by creating this data set. It shows the limitations that the authors have listed for their data sets, and of course is fully referenced as would a normal article. They're short and templated, so they're designed for maximum clarity, both for humans and machines, and with a custom workflow to guide authors unfamiliar with data publishing practices. They make a very fast, efficient, and easy way for authors to gain credit for publishing their data sets. The peer review process, as I say, is very short. At the moment, we're running a 53-day average time of submission to acceptance, but I think we're probably going to get that down roughly about a month, I reckon, before the end of the year. And the peer review process involves authors depositing their research data, filling out the templated article, submitting it as they would to a normal journal. But as well as having academic peer review, we have an in-house data check from our team, the research data team. So this is a check that looks for, are the data accessible? Are they in the right repository? And if they're not, we can give feedback to the authors so that they know exactly what to do to get their data in the right state. The submission system is tailored so that the authors have access to on-hand expert advice from my team. So at the point of submission, there are links to our recommended list of repositories so that authors can look through and see which repositories suit their data. They are prompted to declare that they have submitted it in a data repository so that it's clear. However, if they are unsure or would like to require assistance for this, we have integrated research data support services, which means authors can request assistance, and when the article is submitted, a member of our team walk the authors through the data submission process and can help curate the data so that the metadata surrounding it is accurate and rich. So these can be used for all sorts of ways, and we're trying to encourage authors to gain credit for data that they've produced, but have not necessarily got to the stage of having a full research paper. So this is an example of a data note, a standalone data note. Here the authors have some RNA sequencing data. They have not yet used these data in a full research paper, but they want to get credit. They want to get citable credit for the work they've already done. So they've published a data note describing the sequencing data they've produced, which looks like this on the website, and contains a table that lists all of the data sets as part of their data note. So in the table, you then get a link to all of the data sets in a public repository. So the authors will get credit for producing this data, but the research community can also use these data in subsequent research projects. You can also, however, use these alongside a research article. So for example, in a different journal, BMC Cancer, this is a study looking at genetic determinants of breast cancer in Sri Lanka. The authors published this article in 2018, so last year. Subsequently, though, they wanted to make the data available for the community, not just list that the data are available on request, but have the data in a community repository, in other words, making it fair. So they published a data note with us, and we can link these two together on the website. So you see here, there's a little notice on the research article stating that there is a data note associated with it. And in BMC Research Notes, they have the data note that describes the data sets that they have now deposited and made available. The data note itself then links back to the research article, so anyone who discovers the data will be guided towards the full narrative science research paper and vice versa. So this allows authors to really maximize the number of people who are reading their papers and using their data, which also means they're maximizing the number of citations and the impact that their research is getting. We also consider data notes an excellent way, data notes, but data descriptors in general, an excellent way to increase the findability and accessibility of your data. Your data are not just on a website or on your laptop or USB stick that you can then give to other people. The data note, because data notes are indexed like any other research paper, scientists can find your data sets through, say, PubMed, as the journals are indexed there, or PubMed Commons. So these are examples of where published data notes, in fact, it was the example we showed before, have been indexed in external services, allowing the research community to find those data and use these data in their subsequent research projects. So thank you very much for your time, and apologies for the technical difficulties we had there. So yes, my contact details are at the end of that slide there, along with the website for our research data services. Thank you very much.
Yeah, thank you, Mr. Samuel, for such a nice presentation. I think Subra is disconnected now. Yeah, she is there. So Subra, you can please add on to this.
Yeah, so from the perspective of science communication, I think what Samuel has told us today about how to make the data primarily discoverable and usable. These are the two things that that people in the research community always struggle to
sort of figure out how to do. And so from the perspective of communicating their science to a larger audience, number one, and for themselves to make use of data that would be useful for their own set of research, papers or research in the lab, whatever, for the manuscripts as well as for the core research. I think one of the things that Samuel has really emphasized is how to also reproduce the data that can be used again and again from various sources that he's pointed us to. So yeah, I think that's fairly something that researchers today look for and would gain immensely from this kind of services that Samuel and his team provide. I think if we have questions or if we have any discussions that have come up during Samuel's chat, Rita, are you happy to take them?
We will here take 2 minutes break. We are waiting for the questions. So if we received any questions in these 2 minutes, then of course we will go ahead with these questions. Otherwise, yeah, we have to bind up the things. So let's break for 2 minutes. If the participants have any questions.
Yeah, in the meantime, probably we can ask Samuel some questions from our end. And Samuel, how has it been working with data primarily? What is your biggest takeaway from working with data so long?
The biggest takeaway that I have personally come across is that researchers have very different needs and very different barriers and motivations. Not all researchers are the same. So for someone who's working in public health, for example, they have very different caveats and difficulties with sharing data as someone who's working in physical sciences or engineering or something like that. For example, in public health, you have questions around the sensitivity of the data or the privacy associated with data sets. If you're working in perhaps material science or engineering, you might have intellectual property elements associated with data. And so whilst we would say that we want to encourage data sharing across all disciplines, we have to be attuned to the fact that researchers have very different needs and very different barriers. There are ways, just because I've mentioned public data, there are ways of sharing data from, for example, public health associated with patient data that doesn't impede privacy around patients, for example. There are repositories dedicated to clinical data that allow controlled access, so they can't just be used by anyone. And there are ways to anonymize data that allow you to share the meaningful results without harming the sensitivity or the privacy of the data.
Right, and I think we have some questions coming in on similar lines. I mean, you talked about public health data, and there's a question from Kavita Chadda about fair data being more common in science, not in social sciences and humanities. Why, and how can that be made more common in social sciences and humanities? Sridhar Gautam also asks that question.
Yeah, that is completely accurate. I think we're seeing a much larger take-up of research data sharing in the natural sciences than in humanities and social sciences. I think there isn't one answer as to why that's the case. I think there's a historical element associated with that. I think as well, because in humanities and social sciences, it's more common for a single researcher or a small group of researchers to spend a long time gathering the data that can sometimes be almost their life's work, that then to release that all before, say, they've published their monograph is less likely than scientists working in genetics or clinical sciences, where they have a large number of data sets that they're producing a lot and sharing. However, we are seeing this change, and there are several groups in the European Union and in North America, at least, who are looking to establish humanities-specific sharing practices to allow humanities researchers access to the kind of repositories that are perhaps more common in, say, biological or life sciences.
Yeah. Can you give us an example of one of those repositories or one of those movements in Europe that you're talking about?
So I believe there's an initiative called Forum X at the moment, which is looking at establishing practices for linking humanities and social sciences. I would have to look at specific repositories, and as I say, it's far less common in humanities and social sciences to have dedicated repositories. But generalist repositories such as Figshare or Dryad, for example, are seeing a greater uptake of when it comes to the sharing of humanities and social science data.
Mm-hmm. Right. Another question that has come up is, should we have open research data portal for India on lines of the Open Government Data India?
Well, that's quite a large question. I would hesitate to put my own opinions across on that. However, I would say that I would encourage all funding institutions and governmental organizations to look seriously at open data, because open data is only going to grow. It is only going to become more embedded in research practices, and anything that governments, funders, institutions can do to allow their participants access to the kind of information they need to share data, and funding perhaps where available, is only going to be a good thing. I would say that in an ideal scenario, we would see funders, institutions, and governmental bodies looking at enhancing community-based sharing of data. I think that's very important, rather than trying to reinvent something that already exists. Trying to encourage researchers to deposit their data in already established community repositories, I think, is very important. But certainly there's the European Open Science Cloud, and I know that the European Horizon funding projects are taking open data very seriously, and so I'm sure that research in India will be along similar lines.
Yeah, so India's government policy does have a very big slant on towards open data, and we do have some policy frameworks in place. The only problem with the Indian science community has been the implementation of that policy. You know, we do have a very robust policy by the DBT in place. However, not everybody is sort of come to terms with the policy yet and implementing it properly. So yeah, that should enhance the profile of open data in India, and that should, if properly implemented, take it further. Any other questions?
So I believe there's one that's just come through to me, I think.
Okay.
So the question is there any open archive of research data where researchers can upload the research data which was developed but not used for their research projects? Which is a very good question, and the answer is definitely yes. There are, I'd say, most of the repositories that we would recommend are repositories that it is absolutely possible to upload the data that are not associated with research projects. And I think that's a really important angle. I think we have to move away from the idea that when you produce research data in the course of your research, that is only valuable when it becomes a research paper. And that's not the case. If you have a set of research data, even if you didn't find anything that may look particularly important at that point in time, it's useful for someone somewhere, and perhaps in the future it will be useful for yourself as well. And so putting it in repositories so that it's accessible, and so that there's a timestamp saying this research group produced this data at this time, and we are now opening it up for the research community, is a behavior that I really think we need to encourage, and that we are seeing changing. So, for example, Figshare or Dryad, and I believe GenBank and SRA, you can upload your data there, and it doesn't necessarily have to be used in a research project, as in it doesn't have to be used in a research paper. But also, it doesn't stop you from then creating a paper later in time when perhaps you've done more research, or you've filled in that missing piece that you were lacking to be able to create the perfect paper that you wanted. And I think it will be very beneficial for science if we have the behavior of opening up research data at the point it's created, rather than waiting for when research papers are published. So yes, in answer to your question.
Yeah, and if I may add to that, we now do have journals dedicated to failed research. So yes, so those kind of compile those research stories that did not make it to proving the hypothesis or getting the data out there, in the manner they wanted to. So that is also, again, something really important for communities, scientific communities, and research communities to look at, to find data that is that did not make it to the finish line, probably.
Absolutely, yeah.
Okay, so you just how can we ensure the validity and reliability of data shared in open access?
So
that's another question that's come in. Sorry.
yeah, no, that's a very good question. I think if we're talking about open access journals, then journals should have the data that are published there should be peer reviewed. And so, for example, in the journals that I was pointing out, Scientific Data and BMC Research Notes, they both have dedicated peer review of the data sets. So they should be as reliable as any form of peer-reviewed data. If we're talking about data that is just in a repository, that is just in an open repository, not associated with any review, that's slightly different. There are repositories that do have their own sort of quality control, but that varies from repository to repository. I think it's one of those things that is an element of trust on behalf of the research community. But also, I think if you're looking at the raw data, we're not advocating that people just simply use the raw data, just copy paste the raw data. One should look at those data sets and use them in research where possible, but it's perfectly permissible to run your own research project on top of those, to analyze them yourself and come to your conclusions. Good research data should be associated with the sort of metadata one needs to take a judgment on its quality. So, for example, the metadata around the methodology that was used to create that data set, was it an established methodology or a new methodology, that sort of thing. And also it should be associated with the names of the researchers. So being able to ask them any queries around the data is another important aspect.
Another quick question that has come in is, can we take legal action if the shared data is found fabricated?
Ooh, that's a difficult one. I think that's not something that I would be very confident putting a final answer to. I suspect that would be down to the institutional policies. So depending on the institution that the authors came from, highlighting it to the institution, highlighting it to the repository as well, so that they could take their own actions. I imagine each institution would look at those on a case-by-case basis, and if data was found to be fabricated, there would be this similar kind of responses that you would get from institutions when research papers were found to be fabricated.
Yeah, I guess so, yes. Another very easy question, I think, is how can one researcher use the research data of another researcher for getting research grants, and would that be allowed for a grant?
So just looking at the use aspect of that question, we would advocate that data are allowed to be reused. That's part of the FAIR acronym for data, is that the data should be reusable. So that means the data should be distributed, and if they're in a public repository, they usually will be distributed with a license such as CC BY, for example, that allows researchers to use that data as long as the proper credit is given to the researchers who created it in the first place. With regards to how that works within a grant system, that would depend entirely, I think, on the grant that was being applied for. It would have to be made clear, if you're using data from a public repository, you have to say where the data is from. That's part of the Creative Commons CC BY license. You have to say where the data came from. And so as long as there was clarity and transparency, and the funders who were looking at your research proposal knew where the data was coming from, then and they were fine with that, then that would be fine. The only issue would be if you were taking research data from a public repository and not saying where it came from, and not saying that it was created by someone else in a different research environment.
Yeah, it's perfectly wonderful. It is the norm to be transparent in where you're getting your data from, and most funding agencies now have a CC BY policy as well. So the research that they give a grant for or fund is expected to get back to a place where it can be shared data, it can be open access, it can be fair, as you point out. So there should be no problem in telling the grant agent, giving agency where your data came from.
Yeah, absolutely. And as you say, many funders at this point are moving towards mandating that the data produced by these funders are left open. So I know that in the USA, a lot of the NIH grants, if not all the NIH grants, are dedicated towards having those data open at the end of the research project funding cycle, as are the European Horizon grants. And I'm sure around the world similar things exist. Often the funders, it's in their interest to ensure that the data they're funding is available for future research, because it increases efficiency, it increases the scientific output, and is better for science in the country or the institute. I've got another question come in that says, can researchers or organizations sell the research data for other researchers? Is there any such system that exists in the world? And this will add more to the research data. So of course, it's perfectly possible to sell research data. I imagine that this would only take place where you're not depositing data in open repositories, or rather, you wouldn't be prevented from selling it if it's under a CC BY license. If it was under a CC BY NC, so that's the one with the no commercial clause, then you would not be able to create a profit from that. I would say that it's actually slightly more detrimental to science to have research not available to the research community and instead just being sold from researcher to researcher. I understand that there are situations where that is inevitable, particularly if you're working in environments where there is a very strong practical application. Say you're working in material science or engineering, and what you're creating has intellectual property around it. But still, having the data associated with that open has been shown to not just increase the recognition and impact of research, but it also actually does increase the financial benefits to society by having that data open. So we saw from the Human Genome Project there, the data is entirely open, and the estimated contribution to the US economy is over $1 trillion. If that data had been kept private and only sold, say, to commercial companies, you wouldn't see that kind of societal benefit.
Sure. Rita, you have anything else, any other question there that you want to flag?
Yeah, I think there is no more questions reflecting on the screen. So thank you, Mr. Samuel and Ms. Subra, for such a nice deliberation and joining us for this webinar. And certainly we will compile these questions, and if some of these questions we can raise during our forthcoming conference, ICDL 6 to 8 November. So thank you once again for joining us and for such a nice deliberations. And we will upload the video of this webinar in the YouTube, plus this will be available through ICDL website. So those who have missed this webinar, they can of course access this webinar video at ICDL website. So once again, thank you very much for joining us.
Thank you, my pleasure.
Thank you. Thank you. Thanks very much. Thanks, Samuel.